Robert and I originally talked about this, and some of you have probably heard me talk about this before, but we're still kind of discussing our pilot project that we had going on here in Kansas. It was a 2-year project. It was very intensive, hundreds of thousands of data points. We'll kind of get into that, and then we'll finish up on kind of some of the what's on the horizon out there as far as animal ID. You know, we've talked a lot about low frequency. We've dealt with that for years. They've been around for going on 20 years in some cases. But what is out on the horizon in the RFID world? We'll talk a little bit about that at the end. So the NAIS pilot project that we had going on in the state of Kansas in conjunction with K-State, kind of to boil that down into a nutshell in a few minutes, is we purchased 3,000 tags from 5 different manufacturers. We ran a whole variety of tests in the laboratory on those tags, from how far would they read from a reader, how fast would they read going by a reader, just a wide range of tests. We tested each tag about 10 times, different ways we could read it, different orientations that it was presented to the reader. We had an oscilloscope that we tested how much energy it took to turn on that little tag and what frequency that it sent back. And that was critical to us because of the ISO performance standards that have been put in place for the manufacturers of those tags to follow when they're building them. So we did all that, a lot of data points, very labor intensive, and then we took the middle subsection of those tags, the middle performers. We didn't take the best performers, we didn't take the lower, the goal was that if you as a producer walked into the animal health supplier, bought a set of tags off the shelf, that's about what you're going to get. We're not going to give you the best or the worst, we're taking the averages. So we took those, we put them in animals, and we followed them through the production cycle, through the livestock markets, through the feed yards, and eventually collected those numbers in the harvest plant. Some of the benefits and some of the issues that we ran into we'll get into now. And one of the big deals that we found going from the producer side up to the feed yard, there's a big difference in the reader structure. And when I talk about reader structure for my portion of this, we're talking about a stationary, not a handheld reader, kind of a big panel reader that some of the distributors have or some of the vendors have over there that the animals will run through at the livestock market, or they'll go through at the feed yard or at the packing plant. So I wanted to get into some of what we found out. It was really interesting to me as in my former life when I was actually out installing these readers and couldn't figure out why sometimes they would work and sometimes they wouldn't. But just to jump into this, one of the key things that we found, and I don't know what the magic number is and why it kind of boiled down to this, but the reader structure, in order to get animals to flow through a reader system and read at a high rate. We all hear these horror stories, if you've been around the RFID very much, that we sent some tags to the packing plant and they didn't read. Or we tagged our cattle, we went through all that effort, we put tags in, and they didn't get the reads at the sale barn. But what we found in certain cases, as I mentioned in my prior life installing readers, that they didn't work, we always kind of that garbage in, garbage out. If you just throw up a panel reader and expect it to read, normally it doesn't do that. But so what we really spent a lot of time in developing the reader system, and there's kind of 2 key points to this little chart that I have here. For some reason, the 20-foot distance there from the time the animals enter this little single animal alleyway to the time they exit seems to be the key. The longer we can make that, the better. If we get much under 20 feet, they're still fighting to get single file when they go by that. And that's one of at current, one of the downfalls of low frequency. Animals have to be single file when they go by. I have heard here in the last couple of weeks that some people are trying some new systems up in Canada that we don't have that tag collision problem, but from my experience, you do run into that if you have multiple animals in the reed field at one time. So just a quick picture of a double alley system that we put in sale barns. We worked with 15 different sale barns across the state of Kansas. We had a nice demographic spread from the smallest market in the state was about 5,000 head a year up to the biggest sale barn in Kansas and Salina. There's 250,000 head a year, somewhere in that ballpark. And the second, other than the length of this reader system, the second main and the critical point that we found is prior to that reader in that little 4-foot section, there's a break between the actual alleyway and the reader system. And this really improved, as we put that break in there, we really improved our read rates because of the harmonics, those animals are fighting around in there to get single file. When we separated that, the read rates went way up. And after we got done with all the data set and analyzed the data, we had about a 96 to 97% read rate across the board on the tags that went through the sale barn. And I really honestly didn't expect it to be that high. But the key take-home message for me was that the reader structure is the critical point. Even more critical perhaps than the individual tag or reader that was installed there. If you build the system right and get the animals to flow through, that's when you really increased your read rate. And then we also looked at just a low-cost solution. So here we have a 10-foot alleyway from Molly Manufacturing in Lorraine, Kansas. And then I wanted to keep with that distance. So we had 4 12-foot panels that we used to flow the animals into. And I have some videos here of kind of animals flowing through each one of those systems. But we got really good read rates out of this, even with some of our poorer performing tags in our data set. Here's the reader system that was in place at Salina Livestock Market. Kind of blurry picture right now, but there's 3 different alleyways that the cattle will flow through, 6 different readers, 1 on each side of the animal. So we'll just let it roll through. And one of the big concerns, and we've heard it over and over and over, we just get beat over the head with it, is can you do this NAIS system at the speed of commerce? And Mike Samples at Farmers and Ranchers in Salina, he wanted it to work. He's an early adopter, but he didn't believe it would work. And he took a big step of faith. We spent about close to $40,000 putting this system in. This is the high cost. Can you do it at the speed of commerce? Can you do a lot of cattle coming out of here and not slow my sale down? So we slow his sale down, we're done. But as we can see, the animals, everybody asks, well, the horns are going to tear up your system. The cattle, if you get them settled down in there, the ones on your right-hand side, they fight a little bit over here, bounce off the walls. It's not affecting the reader system, and they go through and they go right to their home pens. So again, my take-home message was that the reader system is critical. Now, just a quick video of the portable unit. These are some cattle coming off the truck at a feed yard. Again, we have the 12-foot alleyways or 12-foot panels behind them to get them calmed down as they come off the truck. Single file them through there. The tag's going right through the reed field in the perfect location. Just works pretty well if you get the animals calmed down before you get them in the reader. We tried several times to eliminate those 12-foot panels. Cattle were jumping over each other. We had them go down in there. It was just a mess. But for some reason, that 20-foot span seems to be magic, the magic scenario. Okay, to kind of wrap up the low frequency side, again, we're at the 50,000-foot view. We have a lot of history with the low frequency. It is a passive technology, so the shelf life, if you will, in that animal, if we can keep it in the animal, it is indefinite. And we can read it multiple times without worrying about some of the other stuff that we face as we move into the different technologies. And the key for us is the ISO standardization. So it allows for the cross-compatibility. I can use Company A's reader with Company B's tags. It just allows for that cross-compatibility. Some of the issues that we have, and everybody talks about it, read range. We have a limited read range. Got to have those animals single file. We can't read them in a 10-foot alley going down, like in a video that we'll see here in a second. The readers are much more complex on the low frequency side, more labor intensive to get them set up, more structure needed to get that to work. And then we have the tag collision. I haven't seen it work yet. I've heard some good stories out of Canada that there may be some issues resolved there. So now let's move on to the what's out there on the horizon. What's the carrot on the end of the stick that may help us improve our overall the overall palatability of an ID system out there to the producer. And I was glad to hear both docs, if you will, talk about the management aspect, and that's one thing that always gets lost in this NAIS talk. Especially, I spend about 90% of my time going out and talking to producers and producer meetings. It's one thing that they don't hear enough about is the management aspects of that tag, and I was glad to hear that. So as we move up, just a quick shot of kind of sometimes we have a hard time getting our hands around what is this next evolution of the RFID world and that product. Just a picture of the radio frequency spectrum. High frequency tags running there in that 13.56 megahertz, all the way up to the ultra high frequency out there at 2.4 gigahertz. So that's what we'll be talking about here for the next bit. Here is a video of some of the brain just went down. Southfork Solutions. Cattle coming off of a truck. Now we're able to read those going down an alley at the speed of commerce. There we caught those numbers. I may need to play that again just to get it to go. So we were expecting 20 head, so we typed in what was coming off of the truck. Read 20, just like that. We didn't have them single filed. We didn't have to narrow them down. Nobody was fighting to get through an alleyway system. So those are some of the things that are coming about. But one of the things that, and we tried to do in our pilot project with the NAIS pilot project, to date, that's still the deal out on the horizon. These tags aren't being manufactured. Me as a producer, I can't go buy them. It's still all in development. Maybe it'll catch up here. So some of the benefits of these of this emerging technology: much greater read range, and a lot less complex readers. So like in that last picture, it's a little bitty reader, maybe a 4x4, bolted up to a pole that's reading all those cattle as they run by, versus what we had there at Salina, a $40,000 reader system. So there are some benefits there. Less complex, and tag collision is not an issue. But as we gain all these caveats with the high frequency technology, we move from that little bitty passive tag that's pretty robust, just a little bitty copper wire with a computer chip attached to it, to something like this: circuit board, circuitry, internal battery. So we add weight to that tag, and that's one of the big deals in retention, especially in cattle and sheep and goats, for that matter, and swine. The heavier that tag is, the higher chance it's going to fall out. Let alone the other management aspects, like talking to Ted, of people leaving bail strings on and that. But the heavier the tag, the more apt we are to lose it. But as we increase that the technology in that tag, we move from that passive system to these active tags that are sending out their energy and powered by a battery. So that is one of the downsides to this technology. Some of the potential issues that we've seen as far as testing them in the lab at K-State, moisture affects them. If they're wet, they don't read as well. Some people have said that they're starting to figure out what's causing that, but if those tags are wet, sometimes the reads virtually go to zero on some of the technologies. In a packing plant, most of the time those cattle, when they're going down the rail, they're wet. Not going to work very well in there. The form factor is what I think back to that last picture, a little round tag that versus a bigger tag that's heavier, that has the internal battery, and the battery life is an issue. And as Robert mentioned, what's from a producer, they're like, a lot of times to me, the analogy that I come up with is they're like a squirrel out here in the forest chasing his tail around looking for that nut that he buried somewhere that he can't find, because he doesn't really have a clear picture on exactly, what's the solution. A lot of the producers, the ones that aren't the big beat the drum anti-NIS, just tell me what to do, tell me what tags to use, and we'll move on down the road. So what we're trying to do with this ASTM standards committee that Robert mentioned is we're working with most of the tag manufacturers in the room, have been a part of this, been to our first initial meetings. What we're trying to do is create a set of performance standards that a tag has to meet, and a reader for that matter, in order to be able to sold on the market here in the U.S. We have international standards for different countries. One of the benefits that some of the other countries have over what we're facing today is that a lot of the other countries that have a mandatory ID program are not facing this technology neutral stance that we have to abide by. It kind of handcuffs us, but we're going to have to deal with it. So we got to learn to work around it. So what we want to do with this performance standard is just measure a bunch of tags and be able to tell that producer that these tags have been certified that they have met the ASTM standards. It's like the good housekeeping seal, if you will, for RFID tags.